Welcome to the introduction and orientation for the Tektronics TBS1072C model oscilloscope. Now, one of the cool things about an oscilloscope that you're going to find out is this is going to be one of your more valuable, more important pieces of test equipment when you go through and are analyzing circuits, trying to figure out what's going on, and so forth. And the reason for that is because an oscilloscope, what it does is it is able to capture the electronic signal, AC, DC, whatever it may be, and it can give you a visual representation as to what that waveform is doing. As normally we can't see the waveforms as they come through, but this device will allow you to do it. So one of the cool things about this is we can again use it for calibration and customization of our signals depending on what we need them to do. If we need them to rise up rapidly and then drop off fast, we can see if we're getting that type of a signal in real time, and also live. We can make adjustments and it'll adjust for it. It's really great piece of equipment. Now, some of the things that we're going to talk about with these again is the limitations that this equipment has. So this scope has a limitation of 70 megahertz. So that's the fastest type of signal you can send through this oscilloscope. Other models, other brands would have different abilities, different capabilities. This scope also has a maximum of around 1 gig samples per second. So that's how many times it samples the signal it's testing to give you accurate data points on the screen. This one particularly is a color 2-channel scope. So when we get it on and playing, we'll be able to see we've got channel 1 that's going to give us in yellow. Channel 2 is going to give us in blue, and that'll display on the screen, which will be then, again, real nice and easy to distinguish the different test points that we're using. So some of the features that this does have, it is color, which makes it really nice to be able to, again, differentiate the signals. We can compare and contrast. We can overlap the signals and not have to wonder which one is which if we're just using black and white. We'll be able to see it. Again, it's a dual channel scope, and it has color-coded controls. So everything on here that we're going to see, for example, channel 1 is all going to be in yellow, channel 2 is going to be blue, and when we get into our math menus, those are going to be kind of a pink salmon color, and we have white for our reference, depending on what settings that we have. So this is what we're going to use and go over in the process of going through. So to start with, you're going to have your scope. You're going to be connected to power in the back. There is also a USB port on the back that you can actually use to plug in to your computer. There's some software you can download from Tektronics, and you can actually use that to gather a screenshot of what is going on your scope at the time. So you can get very accurate representations because it is the representation. It's just taking a screenshot of it. So that's a feature that we'll let you guys discover on your own as needed. We're primarily, like I said, just going over the functionalities of these guys. On the top, we've got our power button, and also when you have your scope, you're going to have 2 probes. So these are going to be a little bit different than the probes that you use for your digital multimeter or anything else like that. These are specialized style probes. They have a BNC connector, which is a push and twist lock, so that'll go onto one of those. And then your probe itself is going to have a grabber, so a contact point. You're going to open it up. Has a little bit of a hook that's going to come out. That's going to grab onto your components. And then you've also got your ground cord. Now we'll talk about where those go and how those are going to attach, why they're important, things like that. You should have 2 probes, so that way, because you have 2 channels, that way you can measure 2 different things without having to move it. And also, using some of the features of this oscilloscope, you are required to use 2 probes to make them work. To power on the unit, it is just as simple as on the top of this oscilloscope, pushing in that button, your screen's going to light up, and you have a couple of buttons that are going to light up. You're going to let it go through its initial power up and setup, and we will just wait for that to happen. It does take a while sometimes for it to get going. So it'll display the different splash screen, kind of with some of the examples of the waveforms that it's going to be detecting and some of the things that you can see on your scope once you get going. All right, so when it's powered up, you're going to see up here at the top, this run stop button has turned green. Everything else has kind of gone to an off state. And now we have our screen with our waveform sitting right across the center. We've got some information sections, and with that, we are ready to go. All right, with the unit powered up, some of the controls that we're going to go over is going to be basically everything on our top panel up here and what all these different knobs and controls do. When you first look at these things, they can be quite intimidating because there is a lot of stuff that you can do, a lot of menus that you have to get into to find out the areas that you're looking for. So how this is going to work is up here with our lit button that we have right now. This is our run stop button. This is going to put the oscilloscope into run or stop mode. Stop is going to freeze whatever waveforms it has on the screen and locks in all the different settings. If we go and change things, it's going to lose whatever it had and be waiting for the next set of waveforms to come through to be able to display. So when it's green, it's in run mode. When it's red, you hit it's in stop mode, so that way you can also give a visual representation. Is my scope currently actively grabbing information, or is it just sitting there? If it's in stop mode, it's not acquiring any new signals, and whatever it has on the screen is whatever it has in its memory. It's not looking for more. Most of the time, we're going to be running these in run mode, unless there's a specific time where we need to capture a signal and then we want to do a more detailed analysis on it. We can stop it, then we can put in cursors, we can change some of the features, change the scalings, that kind of stuff, but mostly this is just going to be in run mode. Once in a while we'll put it into stop mode. The button right below this is labeled as single. What this does is this, after everything has been set up, all your trigger levels, your channels, all that kind of stuff, you hit this button and the oscilloscope is going to wait for a signal to come by over the predefined threshold to trigger it. And once it does, then it grabs just that one signal, it displays it on the screen and then puts itself into a stop mode. But this is more of an waiting acquire button that triggers it to be like, hey, I want you to do something, but when this signal comes in, then lock it down and see what happens, so you don't have to try to hit the stop button on your own, as long as you get your signals and stuff, and we'll talk about what those limitations are for that one. Up here on the second row, this is your help button, so it does have some built-in help menus, some basic descriptions of what the different buttons and controls and knobs do, so that is kind of a good resource to use. This next button down here, this is your default setup. This is going to be your biggest friend. A lot of times when you're messing around with the scope, you're going in and out of menus, changing things. Sometimes these scopes get a memory and they lock out other options and they kind of get confused as to what's going on. And it's just because there's been a couple of settings that have changed that they're either trying to process or something just doesn't quite get set. It happens quite often. And so you just hit this default setup and it clears the internal memory of it and it just goes on from what it's after. And it just basically is one of your best friends. Me as an instructor, if you say I'm not seeing the signal, I've got my probe connected on, the power's on, the first thing I'm going to do is hit this default setup button and I'm going to clear whatever settings you have in there, and then we'll go back to get you in a signal. This is just kind of a good, oops, I screwed something up, let me start back over without shutting it all the way down. This is one of my most commonly hit buttons after the menu buttons. Down here, some utility functions you can get into. These are some functions. These just are a lot of the different uses you can have with the scope, different modes, different methods. I don't get into those a whole lot. There's not a lot in there that you need. This next one up here, this is your save and recall. This is where you can actually save settings that you have. So if you want a certain volts per division, or you want a certain timing, certain spacing, that kind of stuff, you can save those. You can also use them to save the current waveform into the internal memory of this guy and recall it later. We also use them for saving reference waveforms that we can come back later. This next one is going to be another common one that you guys use. I would not get used to using this all the time, but it does work pretty good for quick measurements. So this is the measure button. So when you hit that, it'll actually ask for some parameters. Do you want channel 1, channel 2? And then it says, what do you want to measure? Your max, your min, your wavelength, your frequency, your average voltages, things like that. This will give you all that information internally, and it'll display it on the screen down here in these two little boxes that they have. So this is channel 1 measurements, these are channel 2 measurements, things like that. A lot of time, like I said, I don't let my students use this button until they get later on in the semester, because I want them to get familiar with how to use the onboard measuring tools, the cursors, and that kind of stuff. This is when we get into projects and things like that, that we just need instant information. We don't really need to be wasting time getting those measurements, because they're going to change. We're adjusting parameters, things like that. This is stuff on the fly. The next one is going to be one of your next most important buttons. This is your cursor. So this is going to bring up dashed lines onto your screen. And so when you push it, you can see they pop up. We have them here. They're set up for time. So you can measure time between events. You can measure time of your waveforms, things like that. And then along with these buttons, they have a lot of different menu options that once you go into them. So the way you navigate those menus is these buttons right here. So these 5 buttons are going to give you these different options here. So like in the cursor menu, I'm looking at time, I can look at amplitude, I can change my screen parameters, I can link it, I can bring the cursor on and off the screen, whole bunch of different options. So when I hit these options, it's going to tell me. So up here, this is my time, puts it into time mode, which it already is. This next one down, if I hit it in this menu, is going to bring me amplitude. So it's going to shift my cursors from being on my horizontal axis, which is time, to my vertical axis, which is my voltage, how large are my signals, and we can go from there. This knob up here is going to control the distance between those. So I can use those cursors to go up and down on which cursor I'm looking at. So cursor 1, cursor 2. When I hit the button, it's going to, this is actually a button as well, so it's a rotary switch, but it's also a button. When I hit the button, it's going to change to the other side. So now I can move this bottom part of my cursors and figure out where, put them on my signals to find out how in the positive it's going, how far in the negative it's going, what's my minimum, what's my maximum. The same things that the measure function does, but this gives you the manual touch and feel of it, which again is what I expect my students to be able to do. So this rotary switch, like I said, also has a push button in it, and that will change the different options depending on what menu you're in. And then these will give you kind of your major functions, and they'll be listed right here on the side of your screen. The next thing that we're going to look at is the actual channel control and menus. So in here we have 2 channels. We're going to display channel 1, channel 2. So when we get into the menu, again, it's going to pull up with a whole list of options. And in this one, we've got the channel position, the offset, your probe setup, if you want to give it a label, and then there's an option for more, things like that. And then down here, this is your menu on and off. So you can hit your button for the menu, turn it on. If you hit that button again, it'll turn the menu off. If you don't know what menu you're in, because if you double hit that button, it turns the menu on, then back off. This one will just cancel whatever menu's on the screen, so you don't have to figure it out. So in your channel menu, again, this is going to be your next most important ones. This is going to be how you'd set up and describe what your waveform is. So your position. The position is going to be this, where is your center line? So when you light that up, you can set it up to, I want to go number of divisions, or I want to set it to a specific number of divisions. So we're going to go to the divisions, use the button to select it, and then as we slide it up, as you can see, my center line for that waveform is now moving. So now if I want to move my waveform up and down, because maybe I have a really, really high positive or a really, really low negative value, I can shift the center line around to be able to display it on my screen. So there's kind of the options for that. The next one down is your offset. This applies a DC offset to your waveform, so you can give it a positive or negative signal. That's not necessarily what you're measuring. I wouldn't mess around with that a whole lot unless you absolutely needed. The other important setting in here is your probe setup. So what you need to do, and I know it's kind of hard to read this on the screen, but in probe setup, it comes up with another menu that says probe type voltage, which is what we're after and measuring, and it has an attenuation. So attenuation, we have to match that up with our probes. So on our probes, we actually have a little slider knob. And over here, we have a 1x and we have a 10x. So these are actual attenuations that our probes will give us. So if we go to the 10x, it means it's going to make that signal 10 times bigger, which makes it easier for the scope to be able to pick it up because that signal's already amplified up. But to make sure that we understand that we are getting an amplified signal and it's not really a big signal, it's really, really small, we have to tell our scope that the attenuation is a 1x or a 10x. So we have to go in and tell it my attenuation is 10x to match my 10x probe. Another thing that you're going to be interested or using, not necessarily interested in, but be aware of, is that your probes are going to add a little bit of capacitance to whatever you're measuring. Just like with any type of measurement, it's going to change it a little bit. So by putting these probes in 1x or 10x mode, it actually changes the capacitance of your probes, which can affect your final reading. Most of the time we like using them in a 10x mode. They are a smaller capacitance, they have less impact on your circuits and things like that. So just be aware of that. If you have your probes with a mismatch, you're measuring, if you have this on 10x and you have this on 1x, your voltage is actually going to be 10 times higher than what it's reading because this made it bigger by 10 times. So if you hooked up to a 1 volt signal on the scope, it's going to look like it's a 10 volt signal. Unless you tell it that the signal it's getting in is a 10x signal, then internally it readjusts it down and says, okay, this is saying it's 10 volts, it's only 1 volt, I'm only going to display 1 volt. So that's the thing that we need to be aware of with that. And then one thing that we also need to be aware of is another limitation that I didn't necessarily cover at the beginning of this, but each of these channels has a 300 volt DC or 300 volt RMS maximum per channel. Meaning I do not want to measure a signal over 300 volts DC when 300 volts RMS is the DC equivalent of a sine wave. So if we were to take that value, we could go through and figure out what would be the maximum peak voltage that we could get. So if we run that calculation real quick, so we take our 300, which is RMS, and we divide it by 0.707, that means that what we can have is a maximum of 424.3 volts peak. Now, it seems like a lot. The voltage coming out of the wall is 120 volts RMS, which comes up to be about 170 volts peak. So, we're about 3.5 times bigger than what we get out of the wall, which, depending on if we're in an industrial setting or not, we could easily have that much voltage. But generally, we're going to be looking at, the 120 RMS coming out, so we're going to be well within the limitations of the scope. If we put too much voltage into there, we can actually damage the internal workings of this device. And then it will not read right, it may not read at all, and we will just then have problems. So that's our channel menus. So in here we have our vertical position, so we don't even have to go into that option like I said earlier with the position and use these ones. It has a dedicated position, so that's what this knob is for. That will just adjust the center line position without going into the menu. This knob right here is going to change the scale. So right now it's set up for a 1 volt peak or 1 volt per division signal, and I know it's kind of hard to read on that. My camera's not focusing in very good. But it says 1 volt per division. So if I adjust this knob, I can turn it so now it's 500 millivolts per division. So that means on my screen, my big major squares that I have, that's now 500 millivolts. I can also change the setting to 2 volts per division. So that same physical space on my screen is now 2 volts per division. And this thing can go all the way up to 100 volts per division, or it can go down as small as 10 millivolts per division. So if you notice, my screen kind of went crazy with that. And that's all it was, is because I was touching these controls. When we get down to this 10 millivolt per division section, what we get is a lot of noise. So our bodies have electric currents running through them. That's going to introduce noise. The lights that we work around can introduce noise. And so when we get down to this small of a measurement, we can actually see that noise come back into place. And it gives us a lot of false data sometimes. If we zoom in too far, we're like, oh, I got my signal, but I really don't. It's just noise. So position, your menu options, and then this changes your volts per division. That will give you all the control you need to make your scale bigger or wider, depending on what voltage you want to look at. Now, the other sets of controls that we want to look at is we've got our math menu here. So this is one of the cool functions that it takes these two inputs coming in on channel 1 and channel 2, and it can actually subtract them out. And we'll get into the reason why when we start doing some actual measurements with it, and I'll show you how this works. It's really cool because when we use an oscilloscope, we have to measure things differently than we did with the DMM. So just be aware of that. So the other menus that we want to go through is our horizontal menu. So over here, this is going to control our x-axis. So how wide we go on the x-axis, the position of our x-axis, we can shift our waveform over, whatever it may be, is all going to be in these signals. So the horizontal axis, we can actually take this and shift it, and up at the top you can see I've got that flag that's moving over. That's saying that's where my center point is. We can set it to wherever we want it, and we can actually say use this as my center point, and it'll automatically adjust. Down here, this knob controls my time per division, so I have divisions going out horizontally. Right now it is set, and this one right above there, it is set to 4 microseconds per division. So I can adjust that, and this can get down as far as it'll go to 2 nanoseconds, or it can go as large as, let me get there, 100 seconds per division. So if you want to see stuff changing in real time, this will slowly display the waveform. And if you look on our scope, we're actually now to the point where we've lost our line because it's tracking in real-time data. So now as you see it coming over, every time this is coming over in 1 second per division, this is giving you like real-time displays of what's going on. The other ones are real-time as well, but we've taken our time and we're only looking at a very small section of it. We have about 10 divisions across, so we're going to get, to see about 10 seconds of time on this. Or if we increase this down to, 100 milliseconds, we're going to be looking at, about a second of time altogether. And depending on what we get into, most of the time we're going to be the milliseconds or microseconds for our time, just because that's kind of our normal frequency range. All right, the last menu that we're going to look at here, this is our trigger menu. So what this is this gives us an option to tell our scope, where do I want you to lock onto the waveform? Because as we know, AC waveforms are always changing. Hence AC, alternating current. It always has a variation to what's going on. Whether it's a square wave, triangle wave, whatever, that signal is always changing. So we need a trigger on our scope to be able to tell the scope, lock onto that signal and display it and show me where. So what we have here is when we get into the menu, we have up here it says what type. We want it to be an edge, we want it to be a pulse width, or we want it to be a rut. So depending on where we look at, we can say, okay, on an edge, going up, going down, when we see a gap of some certain distance, or if we see a valley of some certain distance. Then the next option here is your source. Which channel do you want it to go on? Do you want it to be channel 1, channel 2? Do you want it to be this auxiliary line? Do you want it to be just on a general AC line? Whatever it may be. So we want to tell it, where do I want to trigger on? Because maybe channel 1 set up for information, channel 2 is the signal we want to see. When this one hits, what happens to my signal? Down here is my level. So my level is going to be where exactly, how big of a signal do I want it to go? So if I adjust my trigger, you can see that little line that's moving up on the scope. That is my level. So on here I have it currently set to edge and channel 1. So when channel 1 reaches that line going up or down, depending on how we send it up, which is our next option, the slope is either up or down, then the scope is going to be like, okay, I have my signal, it's going up, it's tracing up, it hits that level, now I'm going to lock in, and that's what I'm going to display on the screen. So a lot of times that's the other problem, is my trigger is not set to where my waveform is. If I have a rolling waveform that's just running across and I can't get this thing to lock into it, I need to adjust my trigger level. And I will show you how that works here in a little bit as well. So the last bit of functions that we have on here, this is another option that I usually tend to have my students avoid, just because this basically does all the work for you of all these different controls. This is the auto set button. So what it does is, after you got your trigger set, you're going to go through and it's going to say, I'm going to do auto set. So it's going to scan the waveform And then it's going to go through and say, okay, I'm going to set my volts per division. I'm going to set my center line. I'm going to set my timing so I can see about one or two, maybe three iterations of this waveform. This does everything for you. Now again, it can help, but it's also nice to know if I need to change it, I can do this manually. So if I hit auto set, it's going to look for the waveform, see what's there, and then change these settings to make it work for you. After that, that is pretty much all the functions that we're going to be using. Again, so like I said, you've got a USB port here. You can put in your drive. You can actually have it save the pictures of the screen for you. Here's going to be your channel 1 connection. This is your channel 2 connection. This is an auxiliary in, so if you want something, another probe or another signal or another system triggering it, this is where we can go to look. And then right here, these two little clips, this is where we're going to put our probe to calibrate it, and we will go through that here in a minute. But that's the basic functions in a nutshell of what the scope is doing, what it's looking for, how to control it, and then we'll actually see it in action. That we're going to be looking at is with our probe and our oscilloscope, we're going to grab one of the probes, doesn't matter which one, and what we want to note is that on this side, this is our BNC connector, and as you can see right here on the end, we've got a little adjustment screw. This is what we're going to use to calibrate the probe to the scope. Now the reason we do that is each of these scopes, each of these probes are different, and what's going to happen is we have to calibrate the probe to the oscilloscope we're using. Because of those minute changes, we can actually get some issues that crop up while we're doing this. So what we're going to do in this case, we're going to take our probe, and again, we have this BNC twist lock connection. So we're going to come down to one of our channels. We're going to fit the BNC connection over top till it slides all the way down, like so, and then we're going to twist and lock it into place. Then we're going to find over here where it says probe comp plus 5 volts. We are going to take our probe and we're going to connect the probe part to the top, and we're going to connect the ground to the bottom, just like that. So then what we are after is then when we get to our screen, we're going to see a little bit of a waveform coming across it. Now it doesn't look like much. One of the first things I usually do at this point is I go back and I hit my default setup. So it's going to go through, put its settings. So now we can see we have a signal coming in, but it's not very clear and it's not very recognizable. So what we're going to end up doing is we're going to double check our settings. So right here down in the bottom corner, it says that we're set for 1 volt per division. Well, we know this probe compensation down here is at about a 5 volt signal. So 1 volt isn't necessarily going to work unless we shift. So if we adjust our position down a little bit, we're going to be able to see all the waveform coming in. So we're going to take this guy and I'm going to move it down so that it sits pretty much on another line. All right, so we're sitting down there. Now we can see our full waveform. Now, as you can see, we're going all over the place because we haven't triggered this properly. So I'm going to come over here to my trigger menu and I'm going to adjust my level until that line comes up and then we see the stable waveform. Because what happened is that line that's moving right now is my trigger. That was coming down here and it was never crossing where it was supposed to go. So now we have no waveform to lock on. It's just showing random noise basically as it's searching for that slope to trigger against. So if we move this up so that trigger is in there, we see our waveform is going to lock in. Then what we want to do is we want to see a bunch of these waveforms. So we're going to adjust the horizontal the horizontal width until we can see down here we're looking at 200 microseconds, 400 microseconds, and now we have a little bit of a waveform that we can kind of play with. We only really need about 2 or 3 iterations of this waveform, and we can have that. The other thing I like to do is I like to pull up my cursors, and I set them for amplitude, and then this way I can drive them up and down and kind of match them on the screens. One of the things that I need to do is, there we go. So I went into functions, and over here we have knob sensitivity, and it says coarse. I'm going to adjust that till it says fine. That way I have a little bit more control in this knob. when I'm using like the cursor. So now I have more control and it's not just jumping around. So when we're compensating our devices, what we are after is we want to be able to have these waveforms look as flat as possible. So my cursor waveform is just that, it's just a reference. So as we can see, my cursor is running right across the top, and there's my waveform that's kind of plateauing, or it's peaking right before and then it dips down. So what I'm going to do is I'm going to grab this little compensation tool. You can also use any other devices that you would, or screwdrivers or whatever that you would like. Just be aware that it is metal and you're adjusting a capacitor in there. So anytime you have metal on metal, it's going to change the capacitance. This one just has the metal tip, so it's not as much and not as bad as it changes it. So then I'm going to come down to my probe, to that little screw that's right there, and I'm going to put my compensation tool in there. And then what's going to happen is, as I do this, as I adjust it, I'm going to make it worse, you know, as it climbs up to the top. And what I want to do is I want to adjust that waveform so that it comes down like this. So one way it's going to get worse going in the up direction, then I'm going to go the other direction, it's going to make it smaller, and eventually it's going to overrun and kind of zero back. What we want is we want that square waveform to be as flat as possible. And then after you make adjustments, you pull your compensation tool out, check it to see if it needs any more adjustment. And if you're using a full metal screwdriver, anytime you put that in there, it's going to change it a little bit. So you make an adjustment, pull it out, make an adjustment, pull it out, and go back and forth until it's done. So now we have this waveform on here that looks pretty good to me. And I can go through with my horizontal triggers, I can change the time, and I can see, you know, there's my waveform as it gets smaller and smaller. I can also adjust my voltages up and down, so if I make it bigger or smaller, it's going to change my waveform as well in volts per division. Oh, and now that I look at it, I am in coarse mode still, so I was only changing it by 1/10 of a volt. So if I go back to my function, take my knobs back to the coarse, and now you can see now I go 2 volts per division, there's 5 volts per division, and I can even make them bigger and have them go off the screen. And obviously when you make them bigger and bigger, you can still see some issues with those, with the edge of those waveforms like we have right there. So that's something we could even go in and we could try to compensate out a little bit more. When we're at such a fine setting, it's going to be really hard. Looks like we're going to still kind of have that dip. But we are also very, very small as far as our voltages go. We're looking at 20 millivolts per division, which is really, really, really small. Okay, so come back and look, just make sure we're still compensated, we're checked out, we're flat, and that's what we're after for when we want to compensate our probes. Now, these probes are going to be calibrated for this specific oscilloscope. And if we ever change probes or if we ever change oscilloscopes, then we need to be able to bring these back as well. All right, so now we're going to take measurements with our scope. So over here, we have a basic circuit connected up with just 3 1K resistors. We've got the positive and the negative coming in from our power supply. So in this case, we've got a Regal DG1022. This is one of the ones that we have on campus that we use. So we have set it up for a current frequency, and we've set it up for a max voltage. And we can look and see there are the settings right now. All right, so what we're going to do is this circuit has been turned on and is engaged. Now we're going to use this oscilloscope to make the measurements for this circuit. So on our probe, we're going to have one probe connected and we're going to work with the other. We have to have the ground connected all together. So the ground and the negative of our circuit are all going to be connected together. So we take the ground, we connect it to that leg because that's where that negative is. Then I'm going to take my probe and I'm going to use it to connect into the top part of my circuit. So I'm connected across the power supply and across the entire 3 components of the circuit. Now, when I come over here to my scope, I actually have it already set up, but to walk you through it, I'm going to hit default setup just to show you guys what's going to happen. So when I first turn it on, this is something that I could see. A lot of information that's kind of jumbled together. So when I'm looking into it, I know that my frequency that I'm looking for is right around 3 megahertz. So, and if I come down here, it tells me, hey look, it's measuring my frequency at 3.14152 megahertz. So what I need to do is I need to change my settings so I can see this. So I come to my horizontal settings and I start adjusting them, and now I'm getting into where I can actually see my waveform. So then when I bring it down to about 2 cycles of my waveform, I can look down and I'm at 40 nanoseconds per division, which roughly translates into the values that I need for the frequency that I'm at. Also, I have it set at 1 volt per division. So each one of these major divisions coming up, I've got one there, we've got one there. So at 1 volt per division, I have a 5 volt peak to peak signal, meaning 5 volts from the top to the bottom. And I'm getting about 2.5 on top, 2.5 on bottom. That's just how sine waves work, with no kind of offset or anything like that. It takes your peak to peak value and goes from top to bottom. All right, so there's my waveform. And now, like I said before, I don't normally condone doing this, but we can use our measure functions. But first, I'll just kind of show this with our cursor. So I'm going to go to our cursor mode, and I'm going to go to the amplitude setting. Now I'm going to have this, and if you see, it's kind of jumping around pretty quick. That's because I'm in coarse mode. So if I go to functions, change from coarse to fine, and we'll get rid of that movement. We'll go back into cursor, pops the cursors back up. So now I can adjust this knob until it just barely touches the top of that. I hit the button, push that down, that brings me to the bottom. And now I can adjust my bottom section until it just barely hits that. So now what I'm looking at is about 2.6 to 2.4 negative volts, which added together gives me right at my 5 volt peak to peak. Now if I go to my measure function, it's going to pull up a whole list of options. So what we're going to do is we're going to take our channel 1 and we're going to use the dial and pick which one we want. So we're going to go over to peak to peak. So now that's going to show up at our measure section down here. So our channel 1 peak to peak is 5 volts, 5.04 volts peak to peak, which is about where we calculated when we were just looking at it. So I've got a measurement for my base setup. I now know my frequency, which is 3.1415 megahertz at 5 volts peak, which, if we come back over here and look at my settings, 3.1415 megahertz and 5 volts peak to peak. So we're good there. All right. We're going to bring it back down and take a measurement. So one of the things that we're after now is we need to find out how these things are, how the oscilloscope measures. So everything has to measure to this common ground point. Without that common ground, the measurements are not going to be accurate because they're going to be referencing a different value. And we want these values all to reference what's coming out of the generator or whatever part of the circuit we're after. So when we take measurements with an oscilloscope, it differs from that of a DMM. The DMM, you could just take those probes and measure across the resistor, get the voltage. But with a scope, you have to measure a point to ground. So in this case, we are measuring from this point, going through each one of these resistors to that ground point, which is giving us the 5 volts. Now these are all about 1 k ohm resistors, which means that 5 volts is going to get split up 1/3 there, 1/3 there, 1/3 there. So if we take our probe and we disconnect it, we move it over here across this resistor, now we're going to be measuring from this point to ground. And the only thing that's in that point to ground is that resistor. So if we come back over here to our scope, it is now shrunk, and our measurement down here is saying we're at 1.6 volts, which matches the third of 5 volts. So now if I come back over here to my circuit and I go to measure, if I move it up here to this resistor, now I'm measuring from this point through that resistor to my ground. I look at my scope, and now it's telling me I'm at 3.12 volts. So now I've got two different points of measurement. I have 3.12 at this point, and then I have 1.6 at that point. Well, that's good and great if I'm measuring test points, but a lot of the times I want to be able to measure individual components to make sure something's not getting too much voltage, too much power, or I need specifically to see the voltage of a component. With the oscilloscope, we can't directly measure that, but we can do it indirectly. So what I have to do is I have to grab, oops, it's caught, my other scope probe. So I'm going to take my other scope probe, I'm going to connect it in just like I did with channel 1, and I'm going to go through and make sure that this thing is working right. So I'm going to turn off channel 1 because I know what that voltage is, so I hit that button twice, once to pull up the menu or turn it on, a second immediately to turn it off, and I'm going to turn on channel 2. So this time I'm going to connect into here because I need to double check that my probe is calibrated for my probe. And now it's kind of bouncing and flying, and I can go through, so I'm going to adjust my frequency down. And then I'm going to change my divisions for my voltage. I'm going to take this position and I'm going to drop it down because I'm at 1 volt per division. The problem is now that it's flowing through, it's because I'm not triggering on this. So I have to go to menu on my trigger and I have to tell it I want to go to channel 2. And there's my selection. So now as I'm looking, again, this probe is out of calibration for the scope. So I've got to find my probe, take my adjustment tool, and I'm adjusting this until it turns flat. So right about there. Take it out. We're still a little off. Put it back in. I'm going to drop it down just a little bit more. I'm going to adjust my trigger level. As you can see, that line's moving, so now I'm a little bit more stable. And I'm going to adjust that. So I do have a little slight blip on the top, but that's okay for what we're after. So again, like I said, that top of that waveform, you can see it's kind of cutting up a little bit. That actually looks pretty good, but we are generally flat across the entire thing. So now I'm going to take my probe, disconnect it from the compensation, and now I'm going to take my second probe, and you can see we have different colors. So this has got a red band, this has got a blue band. We've got a red band and a blue band, so that way I can tell which one's connected where. I'm going to take this guy, we're going to connect it on this resistor right here, and then again my ground has to come around and connect in where all the other grounds are connected, just like that. Gets to be a little bit of a mess with your wiring, but as long as you know what you're looking at, you're going to be fine. So we take that. Now we come over here and we look at our display. I'm going to up this scale for our horizontal a little bit, make this a little bit thicker, or a little bit better, easier to read. Okay, and I'm still bouncing as you can see, so I've got to adjust my trigger level to bring it down into where it'll trigger on this waveform. So now I can bring channel 1 back in. So this is the cool thing, is I've got channel 1 and channel 2. They're both sitting on different lines. So what I can do is adjust these so they go to the same line. So I'm going to hit menu, and we're going to do a position. And right here where it says -2, we're going to adjust that. We're going to set it to 0 divisions. So it goes right to that point. I'm going to adjust my trigger threshold just a little bit. That way it all locks in. So now that we can see, we have two different waveforms. The yellow is measuring from our blue probe, which is measuring across this component, or these two components. So this resistor here and that resistor there. The red is only measuring across this one. So as we can tell, we'll go to our measure function. We're going to turn on channel 2, and we're also going to tell it to go peak to peak. So I'm going to scroll over, peak to peak. Close the menu. So now I've got my two measurements.
Channel 1, which is across two components, is at 3.04. Channel 2 is across the one component, which is about 1.5, 1.6 volts. So we're good there. So now what we have to do is we have those two measurements. So the yellow is the total, the blue is just the single component. I'm going to make these one step bigger, so I'm going to increase, still on my fine measurements. So we're going to go to function, and I'm going to change this back to coarse. So now I'm going to decrease the size of my voltages just to make them a little bit bigger and easier to see. Generally, when we do these, we want these to be in the same setting. So I'm going to take them to 500 millivolts each. So now, the cool thing about this is I can come here to my math menu. Pull up my math menu, it brings up a bunch of functions. Source is channel 1. My operator, if I want to add it or subtract it. My source 2 is channel 2. So this time I want to take away the voltage of my blue channel from my yellow channel, and that will then give me the difference, and whatever's left is what is being dropped across that resistor by itself. This is the whole thing, this is part of it. I take this part from the whole thing, what's left has to be across that component. So when I come here, I'm going to take channel 1 and I'm going to subtract, change the operator to subtract. And now that pink salmon colored, that is the waveform from where the voltage that is left over from channel 1 to channel 2. So if I look, channel 1 again is the whole is those two components. That's sitting at 3.06. My channel 2 is sitting at 1.0 or 1.5 volts, and then my math menu is then sitting at 1.5 volts as well. So we're going to go to measure. We're going to come down here. We're going to tell it our math menu. So that was actually just the settings of what it was set to, 1 volt per division, and then it's time based. So we're going to come here, do peak to peak. We're going to go clear that. So now, down here, this was our math menu settings. These are just like what we have down here. Now I've got channel 1 peak total 3.06, channel 2 1.05, meaning that that math menu has 1.5, 1.6 volts on it. So now I can go through and measure multiple components at once and then subtract them out. I could also go through and move these probes, put my channel 1 on this side, channel 2 on this side. Channel 1 is then going to measure everything. Channel 2 is going to measure those two components. And using my math menu, I can subtract these two components from the total, and that's going to give me that guy's voltage left over. So that's a real quick rundown on how to use the probes, how to measure things, and things like that. The biggest thing to remember, again, is that it's not like using a DMM. You have to go from the point that you want to go, or that you're looking at, to ground, and then you have to kind of use math in there to subtract the differences out to find the individual components.